So with our confidence intervals, sometimes we might have in mind a certain confidence level, and we might have an idea of what margin of error we're okay with. And what we might want to know is how many people should we survey, or how many things should we sample. This idea of finding the best sample size for our scenario comes through with this formula right here, which this formula comes directly from the formula for margin of error, which from what we saw is where you take your z star value times your standard error, which is p hat q hat over n. This, if we used good old algebra and went looking for sample size when solving for n, this is how it would rearrange. So this right here calculates sample size based on we know our proportions, we know what confidence level we want, and we know what margin of error we want. So this is going to give us a sample size. Something that's going to come through is that we should always round up. We'll talk about that again when we get through these examples here. So it's believed that 25% of adults over 50 never graduated high school, and we wish to see if the same is true among 25 to 30-year-olds. So we have this proportion, and we're going to assume that's the proportion for 25 to 30-year-olds. So this is going to be our p hat is 0.25, which means q hat is a 0.75. So we're getting pieces of our information here. In the next part, it says how many of this younger age group must we survey in order to estimate the proportion of non-grads to within 6% with 90% confidence. So they're asking how many. So the idea is we want to know what is our sample size. So that's going to suggest that we need to use this formula right here. Then they have this estimation and they say within 6%. If we want to estimate something within a certain percentage, this is describing what margin of error is. Margin of error describes this percentage above and below that we're going from our estimated value. So when it says within 6%, that's our margin of error. And be sure if it's given in a percentage form to change it to a decimal. So our margin of error is 0.06, and then 90% confidence, then we take our z star, which again, that's one of our key values that we found on this page. So z star is that 1.6449. And this gives us everything we need in order to calculate sample size. So to calculate sample size, we take p hat times q hat times, and then in parentheses, you take that 1.6449, divide that by our margin of error, and square it. So, plugging that into the calculator, you're going to end up with a decimal of 140.92. And while here the rounding rule tells us to round up, really you want to keep in mind that we always round up for sample size. And we'll always round to a whole number as well, because if we're sending out surveys, you can't send out a fraction of a survey. So we're always going to want a whole number here as well. So we round up to a whole number, which is going to be 141. So this tells us that we should survey 141 of this younger age group. So it gives us a sample size to work with that's going to achieve this margin of error that we want, along with this confidence level. It's kind of working those two together. Let's look at this next example where everything's pretty much the same. It's just we're going to change our margin of error to a 0.04. So our formula for sample size, we take p hat times q hat times, and we have our z star stays the same since we're still going to work with 90% confidence, and divide by 0.04 now instead of 0.06. So plugging that into the calculator, you should get out a 317.07. And with this, normal rounding rules, if we're rounding to a whole number, would tell us to round down. However, with finding sample sizes, always round up. So with this, we would actually round up to 318. Why that is because this margin of error that we're allowing, we're saying 4% error is okay. If we round down, there's this idea that smaller sample sizes are going to have more error involved. When we take smaller sample sizes, as we saw with our sampling distributions, it allowed for more deviation, more variability, because with smaller sample sizes, we let kind of the weirder scenarios come in. When we round up, we're creating a larger sample size, and whenever we have a larger sample size, we actually gain more accuracy. So the idea is, if there's the researcher that says, okay, 4% error is okay, if you round down, you're actually letting more error in, and it's likely that they're not okay with that. However, if you round up, you'd say, okay, well, where you wanted 4% error, you actually have a little less than 4% error. That's better. It's better to have less error coming in. So we always round up because larger sample sizes usually have less error. And with that, we're just being careful of respecting that 4% margin of error there.